Call centers are a vulnerable point of attack for large enterprises like banks. Fraud is responsible for more than $20 billion in lost money every year, and a significant portion of that fraud is due to customer service representatives being victims of fraudulent social engineering attacks. Chris Halaschek joins the show today to discuss how Pindrop Security is addressing this attack vector. Every phone call that gets made to a call center has a unique phone print, and the machine learning model at Pindrop Security uses these phone prints to assign a risk score to each call. Chris also discusses the challenges associated with scaling a cloud security company. If you like Software Engineering Daily, you might like checking out our newsletter, Software Weekly. Every week we send a short curated list of articles and blog posts and videos that the Software Engineering Daily team is curating and enjoying. And you can sign up for the newsletter. You can also join the Slack channel or find out how to contribute to Software Engineering Daily if you're curious about being a host. All of that is at softwareengineeringdaily.com. Thanks for listening to this show, and after a quick message from today's sponsor, we will get to this episode about call center security with Pindrop Security's Chris Halaschek. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Chris Halaschek is the VP of Engineering and Cloud Services at Pindrop Security. Chris, welcome to Software Engineering Daily.
Jeff, thanks for having me. It's really great to be here.
Absolutely. It's great to have you. So today we're talking about Pindrop Security, which makes security software for call centers. For people who don't know, what is a call center?
Yeah, so it's a good question. I mean, so we typically work with large banks or financial institutions, and if you think about their front doors, if you will, I'd say there's three of them today. They have their physical branches where someone can walk in and withdraw money or move money around. So that's sort of one avenue in the door, literally physically. Another one is online, so going to a bank's website, and then lastly is through the phone channel. So literally calling into the bank and engaging with typically first an interactive system that they call an IVR, and then eventually reaching a live customer support representative. So the call center is what powers that phone channel, so you can reach out to your bank and engage in various actions like bank account balances and wire transfers and whatnot.
So the people in a call center, they're sitting at a computer. What kind of software is that computer typically running? Do the calls get routed through a layer of software before they pick up the phone?
Yeah. So if you think about sort of the path that a typical incoming kind of call takes, it'll go through the caller's headset, through some kind of origination leg, and then eventually hit typically a telco carrier, like a Verizon, and then get terminated into one of several enterprise data centers. And they have specific applications that will then help route it eventually to a contact center agent. And there's a variety of different software suites out there and toolings that help power that to where they can, answer the call and then service whatever the customer request is. So there is from the call initiation and origination, this path through the telephony infrastructure that eventually gets terminated at typically an enterprise data center and call center.
The nature of call center-based security attacks I think they fit into the category of social engineering. Would you say that's accurate?
Yeah, I mean, there's a large number or various types of social engineering kind of aspects that go into what may end up being a call center attack, if you will. What our statistics show is that typically there are 5 to 6 calls into a bank call center that lead up to what we would call an account takeover. So some fraudsters impersonating you, Jeff, and has gathered enough information to convince a customer support rep that they are indeed you and want to do something malicious.
What kinds of training do the call center employees, the customer service representatives, what kinds of training do they receive to avert this kind of situation?
Yeah, historically, if you look at just the phone channel, they have a variety of different security mechanisms. I will say, if you look at the various channels that you can, effectively attack a bank, the security mechanisms are certainly the weakest at the phone channel. But that's been things typically like, knowledge-based authentication questions. So there's scripting and training for the CSR agents or the reps around these what we call KBA questions, and that's what's typically utilized for them to especially before Pindrop to try to effectively authenticate callers calling in and identifying themselves as some customer for the bank. There's also typically fraud analysts that work with these large financial institutions who are very well trained on identifying bad actors, and we typically work with those teams, and they use Pindrop's solution to assess what we call Pindrop alerts that identify potential fraud within the call center. Does that make sense?
Absolutely. So why don't you walk us through a typical attack that a fraudster would make on a call center? Give us the objectives that the fraudster is trying to achieve and what measures the call center has in place to block potential fraud.
Yeah. So, again, typically what will happen is, the fraudster will first work a variety of different channels to gather information about a particular account they want to target. And so you mentioned social engineering before. So that may involve gathering information like birth dates or perhaps someone's mother's maiden name from perhaps social media, which a lot of this information is now readily available. In some cases, they may also, call the target directly and present themselves as the bank to try to confirm information. So once they're armed with that information, they'll then directly call into the call center, into the bank, and again impersonate that person. And one of the most frequent types of attacks that we block, work to prevent, are account takeovers. And effectively what they're trying to do is become authenticated as the account owner, and then they may want to have a new debit card kind of mailed to a new address that they've updated, and then they have all of a sudden changed the address, and now they have access to a credit card, and then can go and start actually making purchases. Other actions we see related to these account takeover events is they will issue fraudulent wire transfers, and sometimes these are in the hundreds of thousands of dollars, and these amount up to for the industry, in the U.S. alone, adds up to roughly $20 billion dollars in loss due to phone fraud. Does that make sense?
Yeah. So it sounds like you mentioned the social media uh, information that's freely available, and I could imagine this could potentially poke holes in the security models, like what is your first car or what is your mother's maiden name. This is material that the fraudster might be able to just find by having a friendship with somebody on Facebook.
Indeed, and I take a step further too. When we see at times, I mentioned sometimes there's 5 to 6 calls before this type of event happens into the call center, and they will even, extract this information from the agents who genuinely think they're talking to the actual account owner. Yet, indeed, in reality, they're attempting to gather this type of information. Then they call back again and go through a cleaner path to actually, say, execute a fraudulent wire transfer.
So we're definitely going to get into Pindrop eventually and how that works and how you avert call center fraud. But just to touch on this topic a little bit more, should banks be or other call center potential fraud targets as well, I guess, should they be invoking further measures against this type of fraud? I mean, I can imagine you could introduce a whole host of other types of authentication questions that would add more friction at the customer service level, but maybe more effective towards preventing some of that $20 billion in fraud.
I think the answer is they are. That's effectively where Pindrop comes into play. And if you look in the U.S., we're in the top 3 of the 3 of the top 4 U.S. banks. So I think there is they have teams of fraud analysts that are trying to prevent these types of attacks. They're investing heavily in the technology to prevent them. So, I will say this is certainly a very strategic initiative for them. We hear about breaches, not just in banks, but across the board. And, security is at the top of everyone's mind and is, certainly our board level conversations. And we see that within banks as well.
Okay, well, let's get into Pindrop. So why don't you just tell us what Pindrop does at a high level?
Yeah, sure. So, I mentioned sort of the 3 different channels that can be exploited, from a fraud standpoint from banks. So we focus in at the bank call center. And what we do is, we have developed what we call phone printing. And you can kind of think of this as a unique fingerprint for a given phone call. What we do with this phone print is actually derived from or extracted from the raw call audio. So we ingest the call audio from the conversation that you may be having with a customer support representative, and we identify what amounts to 147 different features that we extract directly from this call audio. So this is things like codec artifacts, aspects or statistics around the noise, so things like clarity or signal to noise ratios. We look at things like packet loss, and this is actually a pretty interesting one, Jeff, in that if you look at the path through the telephony infrastructure that a call will take, there are certain kind of effects or impacts on the actual audio that is received on the destination end, and some of that may be packet loss. So these different features or signals, these 147 of them that we extract through our audio analysis algorithms, form this phone print, and this is kind of at the heart of Pindrop's core IP and what we do, and we've patented this. So we take that phone print, we combine it with other kind of information about the call. So think of it as like kind of call metadata, the time of the call and the originating phone number, as well as some other information about that phone number. And then we funnel that through a variety of different machine learning models that we use to assess various kind of risk factors, if you will. And so that is combined into eventually a final risk score between 0 and 100 that characterizes the likelihood that this is fraud. And that is essentially what our customers consume. So we service them Pindrop alerts for a given call, and there is a risk score associated with that, and then they will, assess and, may end up blocking, potential actions that are happening through that kind of call session, if you will.
So when we're just talking about these sonic artifacts that occur in a fraudster's phone print, why, just because of how it's been routed through the telephony infrastructure, why is that so orthogonal to how a legitimate caller's phone print would look?
Well, one is, if it's because we can uniquely characterize the call, and it's kind of independent of what is said on the call, or necessarily the phone number associated with it. We can do some interesting things with that, right? So I could kind of use that to build a blacklist and say, well, this phone print is bad. So if we have very, very similar phone prints, they're likely to also be bad. So it's really about trying to reduce the call to, effectively a fingerprint that we can then do intelligent things with for the purpose of blocking fraud.
Okay. What are the routes that these calls are taking from fraudsters? I mean, why isn't a fraudster just calling in on a cell phone the same way that a normal user would?
Yeah, so that's also a good question. I mean, there's certain things that are easier to do from a fraud standpoint. For example, if you're making a VoIP call. So, a very common thing that fraudsters will do is forge, or what we call spoof, a phone number. And when you're making a call that's originating out of the VoIP, it's a VoIP call that's much easier to do than through the traditional telephony infrastructure. So what you'll see is a VoIP call that will go through perhaps Skype, and then hit a more traditional carrier like Verizon or AT&T, and then eventually make its way through their network, and then terminate within at the bank call center eventually. So that's kind of one aspect of it. There's also just geographically some of these what I'd call kind of groups of fraudsters may work in certain parts of the world, and they just don't really have a choice but to kind of go through a specific path through the telephony infrastructure.
Can a fraudster proxy the phone number he or she is using to look like my phone number? Yeah,
indeed. This is very common and actually quite trivial to do nowadays. Honestly, Jeff, if you went to Google and just did a search for spoofing a phone number, you're going to see a bunch of different services. Alternatively, you can go and kind of build your own using a service like Twilio or Plivo. So it's very common, and honestly, that's what makes it hard to just use a phone number to verify or prevent fraud, because it's so easy to actually spoof those.
Fascinating. Okay, so can you talk some about how Pindrop's software integrates with the phone systems that the call centers have in place?
Yeah, sure. So, we provide a user interface that one fraud analyst and teams of fraud analysts can come in and use. And, that's where they can service Pindrop alerts. So that's a web-based application that they can interact with. So that's one route that's actually quite common. And we have an alert and case manager interface so they can do that. And that's from an engineering standpoint, we have UI development teams as well as robust backend engineering teams to build out this infrastructure. So additionally, we serve up a variety of different APIs that these customers can interact with, and then integrate to whatever their CTI systems, or their telephony infrastructure, kind of on a case-by-case basis.
Okay, so if I'm a customer service representative at a bank, somebody calls in, it gets routed through Pindrop at some point, and the call is assigned a risk score. So I'm I'm the customer service rep. What do I do with that risk score?
So, well, first, let me back up and say, in some cases, it's literally teams of fraud analysts that will, use the product, and they get alerted to high risk calls, and then they may, contact a particular, CSR that's engaged in the call. And oftentimes too, certain actions may be initiated in a call that can be paused or reversed even after the call. In other cases, if there are integrations with the CSR, I just call it the CSR desktop, they may have higher risk treatments in additional questions they could ask when authenticating the particular caller, or they could route it to a specialist who's better trained to actually handle what we think are potentially fraudulent calls or high risk calls.
So you're saying these fraud analysts, do you have customer service representatives, and maybe they don't even need to worry about the fraud potentially, because you have these fraud analysts that will get signaled if the risk score reaches a certain threshold, and if that occurs, the fraud analyst can take action on that transaction between the customer service representative and the person that's calling in. And I mean, what kinds of actions can they take? You mentioned they can take certain measures. Can they make it so that maybe the transactions are easy to reverse? It, like, if you've got like a somewhat medium risk score, maybe you want to go through with the transaction, but you want to make it reversible. I don't know. Maybe you could talk some about that.
Yeah, sure. I mean, so first I'd say I think both the customer support reps and the fraud analysts are worried about security, right? So I think they're all working diligently to prevent it. With respect to the fraud analysts, I think it depends on the type of action that the fraudster is trying to perform. So, and these are measures I think that are already in place. So, if a fraudster is trying to mail a new debit card to a new address, maybe they change the address and they're trying to mail the debit card to that address. There is some time between when that request is initiated to when it actually gets mailed. So there's just the act of canceling that request, and then literally reaching out to the genuine account holder and issuing them a new card. So I think it's going to depend, Jeff, on the type of action that the fraudster is trying to perform. In that one circumstance, it may be changing an address and mailing a new card to themselves, so they can then exploit the account. Others may be issuing a wire transfer and then attempting to cancel that before it actually happens. Does that make sense?
Yeah, totally. So let's talk more about the risk score, because this is the most important component of what we're talking about here. This is the actionable element that eventually gets propagated to the CSR or the fraud analyst. What are the components that go into a risk score, and how do you develop what that risk score is a composition of?
Yeah, so I mean, it is at the heart of kind of the IP that Pindrop has. So there's only so much I can say about it. However, we again, we have the creation of the phone print, that is this composition of these 147 different features of the audio. That is kind of the foundation of it. And then using that phone print to compose the actual risk score. So for us, it is about developing and building new machine learning algorithms that can ingest these phone prints. We also do some stuff with voice biometrics and having voice prints as well, and composing these things through different machine learning models into a single unified risk score. So for us, a lot of the challenges from an engineering and research standpoint are, how do we continue to improve that? How do we from an engineering standpoint, do that at scale? We do this in real time, and then allowing our research team to rapidly iterate on the machine learning models, additional kind of features that could be fed into them to increase performance of the system.
So doing this at scale, does that mean that the source of the training data? Is it all of those calls that are being routed through the different customer service representatives that are using Pindrop?
Yeah, one of the unique things we have to deal with is, there's different types of fraud attacks across different, geographies and customers. So yes, we do have to we tune our machine learning algorithms, and there is certainly a as with most machine learning algorithms some concept of training. So we go through something similar to that.
Okay, and is the source of the training data the call centers that are running Pindrop?
Yes. So, there certainly is training going through, actual real customer data. And there's also, like many machine learning algorithms, feedback loops. So we continue to improve and learn as we're ingesting and even running inside of a production environment.
Interesting. Okay, do you store because it's interesting because I can imagine as you discover new things about how fraudsters are doing things, maybe you would want to rerun machine learning models, or maybe you would want to rerun some older training data through a machine learning model. So that begs the question, like, how long do you save calls for? Because I can imagine that data really adds up.
Yeah, the data really does add up. It's also something that's very sensitive too, right? So, you kind of have to balance all that. You're hitting the nail directly on the head, though, Jeff. That, we have a very, our kind of culture and mindset here is highly research driven. And so in order to improve and innovate, you need to have access to that historical data. And if you look at kind of advances in the machine learning field, a lot of it has been recently because our data sets have gotten so big. So that holds for us too. So we do our best to balance, the cost sort of associated with retaining all of this data, while also satisfying, in some cases, our customer requirements about retaining that data itself.
Can you talk more about the challenges associated with that?
Yeah, there's a couple things. One is that, we run, our products and services run in diverse environments. In some cases, we have components or services that run on premise within a bank call center. In other cases, we run and even strategically try to push as much of that to the cloud as possible. So some of the constraints we have to work within are, when you're on premise versus in the cloud, it's easier to add more resources in some of these than others, right? So part of that is just storage and retention given the available resources we have. And that also means from an engineering standpoint, we need to be very thoughtful about, optimizations and paying attention to certain, components and certain parts of the platform that we build out. And for our cloud environments, we can do what most people do and just scale horizontally, and storage is cheap. So it's something that's easier to solve there, but we've got to be cognizant about running across diverse environments. It introduces a lot of really interesting engineering challenges. And even the way we build our software in respect to that, we try to ensure that we certainly are can run in these diverse environments. So for us, internally, we're heavily investing in containerization of our services. So investing in Docker and Docker orchestration tooling. So from a team standpoint, that's a lot of fun, and it's a fast moving area. So I'd say that's certainly one of the challenges we face.
So to clarify, I think what you're saying is that you have some customers who are entirely on-prem, perhaps some who have hybrid clouds where they're partly on-prem and partly in the cloud. Some are entirely in the cloud, and you need your software to be heterogeneous and be able to run on all of these environments. And you're saying that containerization has been helpful for you there. Can you talk in a little more depth about how you satisfy that heterogeneity?
Yeah. So, from an engineering standpoint, I like to say we think of compute as compute. Like, I don't really care if it's physical appliances running on premise or up in, AWS or GCE, up in Google Compute. So, we, from an engineering and architectural standpoint, we build loosely coupled services, and this is, everyone's kind of doing this nowadays, microservices, and we, through using things like Docker can, from a software development standpoint, in some circumstances, think less about where it's going to be deployed, like physically where that box will sit. Because, as a developer, I just build my service and, wrap it in Docker, and it's more portable, right? So I think I believe if I'm understanding your question correctly, part of it is trying to use tooling that makes our things more portable, so that when we build these loosely coupled services, we're less concerned about where it actually sits. Now, in some circumstances, though, for network taps, for example, or ingesting the raw signal, call audio, that may be a little bit more nuanced and specific to the environment that we're pulling it from. So it's a little bit about trying to focus in on what that service is doing, and is whenever possible, make it as portable as possible. Does that make sense?
Absolutely. Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SEDaily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SEDaily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SEDaily. Thanks to Wealthfront for being a continued sponsor of the show. Now let's get on with the show. So let's, if you can, walk me through the architecture of how a new call would be ingested into the machine learning model. So like if a call gets made to a customer service rep somewhere, and then the call gets saved, I don't know, does it get saved to your servers, or does it get saved to the servers of the company? And then how does that call propagate through the machine learning algorithm? And what does that algorithm, well, it maybe not from a IP standpoint, but just from a like what tools are you using to ingest it and process
it? No, so that's a great question. So typically, if either the call is forked to us and we ingest it in the cloud, or we have a network tap on premise that will actually tap the network passively, and we can consume the raw call audio, and so that's typically in SIP or RTP is the raw call audio. So we ingest the audio packets, and we'll kind of aggregate them together. And then, our architecture, like many nowadays, is we try to build things in a horizontal scalably way. So we will ingest the raw call audio, put it effectively onto a bus or queue, and then we have a series of workers that will pick it up and work on it. So we do a lot of stuff with queuing infrastructure like RabbitMQ. We also use Redis pretty heavily for some things. And then depending on the parts of the pipeline, if you think about the machine learning pipeline, like first we have the raw audio, and we need to convert it into this phone print. So for some of those tasks, it may be better suited for a lower level language like C or C++, or we're kind of investing in Go right now as well. And that may perform the audio analysis aspect and some of the digital signal processing pieces. Again, a queuing-based kind of architecture, if you will. So then eventually that funnels in through the machine learning models. Again, we kind of try to use the best tool for the job. A lot of the ML work we do is in Python today. And then that'll funnel it through the machine learning classifiers and then, outcome risk scores. So, depending on the, in some circumstances, largely the audio is stored today on premise, and there are certain advantages of doing that related to the sensitivity of it. And then, other aspects are run as a cloud service for some of the, when we pull in additional metadata about the particular call, given a phone number, we can pull in information about, the carrier or the particular kind of line type, if you will. Does that make sense?
Yeah, so you're saying after you pass the call through the machine learning algorithm, you save it on-premise or the bank saves it on-premise?
No, so this is actually running within the Pindrop platform. And again, depending on the deployment model, in many cases, the audio would be, if needed, stored on-premise, yes.
Fascinating. So, I'd love to know more about the way that different teams interoperate. Like, do you have a machine learning team? Do you have a I don't know, and give me a description of how because we did some shows about machine learning a while ago, and there was this frequent issue where the machine learning team would work on a model, and theoretically, the model would just get handed off to the production team. But in actuality, there tended to be this friction between machine learning teams and the production developers, where the machine learning team would develop some prototype, and then it would actually be harder to get into production. So I always like to ask, about this area when I'm interviewing a company with a heavy machine learning component.
Yeah, so within Pindrop, we have, a very mature and robust research department that, has audio researchers, kind of audio scientists, data scientists that work on the machine learning models. And, for us, we, I kind of touched on a little bit about, Pindrop's culture and it being very engineering research led. So there's a very close relationship between the engineering organization and the research organization. And, working very closely on making sure our architecture from a production system standpoint enables, our research team to rapidly iterate and innovate on those models. And if you think about, look at like the antivirus space, those get updated, those virus signatures get updated very, very frequently. So we work really hard to make sure we're rapidly releasable and can iterate on these machine learning models and algorithms. And again, I think that is best enabled by having a close relationship between engineering and research. In some cases, research engineers will embed with our different engineering teams and vice versa. So, for us, it's just making sure that we enable the constant testing and tweaking and testing again so we can evaluate hypotheses and then getting that deployed into production, rapidly in a very, safe and controlled way.
What is the pace of the war between spammers and anti-spammers in this environment? Because this is always true. There's like a certain tempo of the war between in every fraudster versus anti-fraudster environment. There's a different tempo of the war. How quickly do you need to process a new call? Do you need to do it like instantly because you need to update your systems very quickly because you're going to get barraged by some new technique every day? Or how time sensitive are these workloads?
Yeah, so I would probably need to defer some of that to part of our research team. It certainly isn't a daily thing. I wouldn't say it's that dynamic. A lot of these attacks build up over time as a result of siphoning information across a variety of different of attack vectors. We, from an engineering standpoint and, from an architectural standpoint, really just work hard to make sure that as they innovate and solve, from a research standpoint, can get that deployed as rapidly as possible. Because at the end of the day, we don't want our customers who are directly banks, but at the end of the day, consumers, we don't want them to, succumb to these fraudulent attacks. So I would say from what I've seen, it certainly isn't a daily thing, but certainly is, evolves more than just a couple times a year.
So, I've been thinking about these scheduling questions a lot lately. We did a recent show about schedulers, and I don't know. It makes me think like how predictable are your workloads, and do you have situations where you have idle machine time, and are you looking to try to minimize that? I mean, you're the VP of engineering and cloud services, and so I imagine that thinking about scaling up and down the infrastructure is an interesting question to you. So I'm just curious where you find yourself with idle machine time, how you're trying to utilize that, or how you're trying to minimize it.
We talked earlier about having, this on-premise in cloud-based presence, and I would say strategically we're pushing more and more of our infrastructure to the cloud. There's a lot of advantages there, and about rapid deployments, whatnot. So that's where we're very actively investing right now and building out our teams. The interesting thing, as you're pointing out, is if you think about for like a bank, just the call patterns throughout the course of a day, you're going to get something like a bell curve, right? Where, from the hours of 9 to 5, that's where the majority of their traffic is coming, and, you're going to see peaks throughout the middle of the day. So, we are actively, investing in kind of dynamically provisioning infrastructure in a fully automated way to minimize costs through these ups and downs, and through the traffic and the load itself. And so that's something we're very, very cognizant of and investing heavily in.
And uptime is obviously quite important for a security company. What's the relationship between your development and your operations team at Pindrop?
Yeah, it's a great question. It's something I'm very kind of passionate about. We think a lot about just in general engineering org structure to make sure the teams are as autonomous and empowered as possible. And for us, the answer there is having integrated teams where if you think about a service or a handful of services that a team may be responsible for, making sure that they can build, test, release, and maintain that. So the model we have, this is, again, I'll admit, a common model. I mean, it's very much kind of follows the Spotify model where, that team that's owning that service can get it deployed into production and maintain it. So, we have embedded DevOps engineers on our teams. Those teams will have, scope and ownership of different parts of our cloud-based infrastructure. And, everyone across that team is at some point responsible for quality, but then, we have different tiers. So, DevOps engineers with some rotation will be the first to, get, alerted after it's gone through, our support tier, if you will. And then eventually, if needed, software engineers get pulled in as well. So again, our kind of approach to this is having, kind of integrated teams so that they can really own services and approaching it that way.
Can you talk more about the broader culture? Because Pindrop is obviously growing quite fast. The team is growing. The product is growing in popularity. What are the difficulties in maintaining the culture that you've achieved throughout this process?
Yeah, Jeff, I'd say, again, that's something else that we're very keen on and pay a lot of attention to. And I mentioned that we have this, what I'd say, engineering and research-led culture at Pindrop. As I look at a lot of, especially B2B startups or companies, you typically kind of have an MBA mindset, or they're kind of sales and marketing led. And sometimes we think of Pindrop as having this PhD mindset. And interestingly, 10% of our staff has PhDs, and we're kind of looking to maintain that as we scale and grow the company. But, so that culture, as I mentioned, lends itself to focusing on the very hard problems. We're literally fighting crime with science, is the way we try to like to look at it. And so that's that culture of constantly testing, tweaking, testing, coming up with these new hypotheses. we have to work to maintain that as we grow. I mean, in 2015, company revenue and headcount doubled. So going through that type of growth, we've got to pay close attention to maintain that type of innovative culture. And so, the way we've approached that at Pindrop is one, making sure we focus on our teams and allowing them to continue to grow and learn, and offering things like budgets for training and conferences. Geographically, we're also located, at least HQ, our headquarters in Atlanta is, walkable distance to Georgia Tech, and we have very close ties to the university there. Our chief scientist, is a professor at Georgia Tech, regularly gives talks, at the company. And I think those types of things have enabled us to, not have our growth and additional processes we've had to put in place stifle our ability to innovate and experiment.
The culture sounds, maybe I'm wrong, but it sounds somewhat like Palantir, because I think Palantir is notorious for not having a focus on sales and marketing people, and they make the engineers do the sales work.
Well, I wouldn't go that far. I mean, we have a very a fantastic sales team.
By the way, I may have totally just misrepresented the Palantir business model.
No. So, I mean, I'd say for Pindrop, look, we, at the end of the day, we are a B2B company, and we have a very, enterprise sales cycle, right? And I would say, how would I characterize it? I mean, I think you can imagine that our engineers and scientists, while they appreciate it, don't really get excited about that. So, we rely on that sales team to get out and get these deals done, and give us the bandwidth and rope to go and build the product and innovate. But I will say, though, the way we just think about evolving the product and improving it is largely an engineering and research led thing here.
So, speaking of engineering versus research, you spent significant time in academia. Can you talk about how the culture between academia and industry differs from your point of view?
Yeah, that's an interesting question. I mean, you're right. I spent, I did my graduate studies at the University of Maryland up in College Park. And, I think when you are pursuing a PhD, you're going, really, really deep on a problem. And I sometimes say you go so deep that only 100 people in the world really care about it. And in some cases that is true. In others, there's very, very broad applicability to it. So, I think the things that you, which I think are good, that you can overlook when you're in academia are necessarily, the market acceptance or, end user kind of value in some cases that the research may have. I mean, in some cases for, if you're studying algorithms and algorithm research, some of the practical applications are less obvious than others. And, at least in startups, early on, you don't have to nearly go as deep before you can try to test and launch a product. So I think, part of the difference is, and depending on the stage of the startup, the depth you have to go to before you've really, proven something out and demonstrated it is kind of one aspect there. I think, though, there are a lot of common things, though. I mean, a lot of it is you're both in academia and in industry, you're trying to innovate and, in many cases solve very hard problems, technically challenging problems. I mean, that's one of the things we do here at Pindrop. And, we have seen, a very healthy kind of relationship between, our academic ties and, our relationship with universities and kind of carrying that into the way we think about solving problems for our customers today. So, I mean, I think there's common aspects. There's some differences as well. I think it also depends on sort of the stage of the startup versus, kind of even perhaps where you're at in your academic career. I mean, when you're first trying to pursue a PhD, you've got to figure out what your dissertation topic's going to be, and sometimes that's even trial and error, which has some common aspects to early stage startups. So, I don't know if that directly answers your questions, but there's at least for us at Pindrop, it's been our roots. Some of the foundational technology transitioned out of academia, and we've had to then figure out how to scale it, package it up in a way that works for the type of customers that we sell it into. So we've had to take it many degrees further from a product standpoint. Does that make sense?
Yeah, my impression of the research side of things when it comes to computer science is that computers have become so prominent and proliferate that it's almost like if you're studying something deeply in computer science and it has no broad applicability, I mean, that would almost be surprising. What are the because you increasingly see companies with longer and longer time horizons on the commercializability of their research. I mean, if you go look at some of the papers that people are writing at Google, it's like, how is this on Earth? How is this going to be useful in the future? It looks as useful as a far-flung academic paper. So, I mean, is there what is the market difference between the type of non-immediately commercializable, perhaps strange research that goes on in academia versus that goes on in industry? Because my impression is just that like they're coming so close together, with perhaps the only differentiation being academia has less of this even distant forcing function on commercializability.
Yeah, I mean, Jeff, I think it's a fair observation. I mean, you even see some prominent academics, and researchers going to large, organizations, and pursuing their research there. And I think it's a fair observation that that kind of delineation is becoming less clear. You also have, more. A variety of different options for partnering up with academic institutions and trying to spin out some of the technologies. Some of those are even government funded, like through the SBIR and STTR research grants that the government kind of pairs you up with an academic. You may pair up with an academic institution. So yeah, I mean, I think it's a fair assessment. And
I suppose there's also the Berkeley Amp Lab side of things where the Berkeley Amp Lab, spun out so many super important companies that are going to be really big in the near future. And if those guys would have been doing their research at Google, then probably all those companies would just be Alphabet subsidiaries.
Yeah, I mean, I think it's fair in that case, certainly. I mean, it's I think with academia and academic research, historically it's been I'd say in many cases higher risk, some of the research projects as far as the likelihood of success or failure from a business standpoint. But as you just pointed out, some of that research now is just transitioning more into some of these larger, corporate entities, and part of that shift, perhaps could be tied to sort of the shifts in the investor landscape and risk appetite, and companies realizing that. Some of the enabling research may come up in non-obvious ways. So,
So coming back to Pindrop to begin to close off, what's the long-term vision for Pindrop?
So if you look at, for us, we really think of Pindrop as, today a voice security company. And, if you look at just voice as a mechanism to interact with computing devices, like voice as a user interface, we think that is going to continue to grow at really explosive rates. And I don't know if you've read, say, Mary Meeker's 2016 industry trends report. Voice.
That's a lot of information. It was a wealth of information.
Sure it is, but she correctly pointed out that just voice as an interface is rapidly growing. I mean, it's really amazing. If you look at like Google Voice Search, it's some of the stats there, up 36x since 2008 and 7x since 2010. So, we think we're going to continue to see that, and we're even seeing that now in the consumer market, right, with the Amazon Echo and Siri, and the list goes on. And really, the longer term vision for Pindrop is we want to be that identity and security layer for all those voice interactions. Right now we're focused on the enterprise, mostly in call centers, but we think just voice as a means to interact with computing devices, be it your watch or your TV or an Echo. You're going to need identity and security solutions for that interaction, and that's where we'd love to end up playing.
So if I'm sitting in the living room with a friend of mine and my friend yells out to my Amazon Alexa to order 50 gold-plated Apple Watches, I guess I would want Pindrop sitting between my friend and Alexa to have some layer of verification on the voice, or what's the security? How does the security or the risk vector of these type of voice services? How does that present itself? We like to think of it as today we're really securing the phone channel in the enterprises, right? And the different risk vectors may change when you start to look at more of these consumer devices, and that's a space where you haven't been active in. But I would say, and this is just me speaking, it's some function of your voice, your location, and perhaps the device. And when you're in your own home, it's probably going to largely come down to your voice. In the example you just gave, again, that's sort of the longer term vision for us. On being that kind of security layer there, but that's, I think, down the road. I love it. That's fascinating. What are there? I'm trying to think of previous companies that have tried to make or have made the jump from enterprise to larger consumer models. What are the typical frictions that you encounter when you're moving from enterprise to more consumer?
Yeah, I think one practical one is just, when you're an enterprise company, your whole sales process and cycle is geared towards just that, right? So you are going to have to adapt and change that part of your business. Other ones from a practical standpoint are just what are the different business relationships from a biz dev standpoint. And then, there's also probably going to be, from an engineering standpoint, scale issues about how you manage that, that transition, so how does the scale impact, your engineering and architectural kind of decisions. So, for us, we think about solving those problems by bringing in, the right partners and investors. And for us, that's, we've been very fortunate to have very good financial partners like Andreessen and Google Capital and IVP, and then building teams that can adapt and build out our infrastructure that's highly scalable and can easily adapt to these shifting kind of usage kind of environments and use cases. Does that make sense?
Absolutely. Okay, well, Chris, this has been an awesome conversation. I'm very interested in Pindrop now that I understand the longer term vision. I was not aware of that. Okay, well, thanks for coming on the show, and I'm glad to have you as a guest and as a listener of the show. I hope to have you back sometime in the future.
Yeah, Jeff, look, it was a lot of fun. I'm really grateful you had me on, and I appreciate it.